Hi everyone, welcome back to Array series. Hope you are doing good. In this video, we are solving Leetcode problem number 88, which is merge sorted arrays. Okay, let us look into the statement of the problem. It states you are given two integer arrays nums1 and nums2 sorted in non-decreasing order and two integers m and n representing the number of elements in nums1 and nums2 respectively. Merge nums1 and nums2 into a single array sorted in non-decreasing order. So it means after merging also the numbers should be in their sorted order. Okay, the final sorted array should not be returned by the function but instead be stored inside the array nums1. To accommodate this, nums1 has a length of m plus n, where the first m elements denote the elements that should be merged and the last n elements are set to 0 and should be ignored. Nums2 has a length of n. Okay, they have given some examples here, and if you see the constraint, the nums1 length is m plus n and nums2 length is n, and m and n lies in the range 0 and 200, and m plus n also lies in the range 1 and 200. Okay, and any number in nums1 array and nums2 array, they lie between minus 10 raised to 9 to 10 raised to 9. Okay, with this, let us switch to our editor and try to understand this problem. So they have given this particular array nums1 and nums2, and if you see nums1, there are m elements, which is these three elements. If you see nums2, there are three elements, which is these three elements. But the three elements which is equivalent to this particular n is given in nums1 array, so that what we need to do, we need to bring these elements into this array and we need to return from there. So that is what this problem states, and also we understood the constraints. With that, maybe what we can do, you can pause for a minute and you can think for any possible solution and you can come back to the video. So now with that, let us try to understand the idea or the intuition behind this problem. So basically, our interviewer will be expecting us to solve this particular problem in O of m plus n time complexity, but with O of 1 space complexity. This is very much important. Okay, so with that, let us try to understand the extreme naive way with which we can solve this particular problem. So basically what we want to do, we want to merge these two arrays and then we want to have all the elements in their sorted order after merge. So with merging, what happens, it becomes something like this: 2, 5, 6. This is after merging. Basically I copied these elements to these values where there are zeros, and then I got this particular array. Then what I will do, I will simply sort these numbers using any inbuilt sorting technique. So with that, what I will get a proper merged, and that too it is a sorted array. Okay, let us try to do that. So now what I will do, I will start from this particular value, then I'll move this value to this array. So how we can do, 1, 2, 3, 0, 0, 0. Okay, basically, and 2, 5, 6. This is nums2 array and this is nums1 array. Now if you see the indexes, so our index starts from 3, which is nothing but the value of m, correct, right? So I will start from here, then I'll start from the 0th index of the nums2 array, then I'll copy and I'll move further. So I'll copy 2, then I'll copy 5, then I'll copy 6. Okay, with this I got this array. Then I will use any inbuilt sorting technique, any inbuilt sorting method, basically not technique, it is sort method. So I will sort this nums of 1. Okay, let's quickly write the pseudocode for that. So now what I will do, I will start from I equal to 0, I less than n, because I need to iterate all these values, then I plus plus, then what I will do, I will say nums1 of m plus I equal to nums2 of I. So this will copy all the elements from nums2 to nums1. Okay, with that, after that, what I will do, I will sort my nums1. So if I sort it, then I will get my merged sorted array. Okay, now if you see the time complexity, what is the time complexity here? For merging, we took order of n time complexity for this merging. Then after that, I used the sorting. So sorting will take m plus n into log of m plus n time complexity. Okay, this is considering we use the best possible merge technique. So if you see, this is our time complexity. Next, what is the space complexity? We are not using anything extra, so it is order 1, so we are good here. Okay, so this is extreme nice solution. If you see, this is comparatively the larger one, so interviewer will not be happy with this particular time complexity. Then how to improve this? Let us see how to improve this. Now, one thing what we know both the arrays are in their sorted order. Okay, if you have already watched my merge procedure in the merge sort video, if you have not watched, I will leave the link in the description. Maybe you can go and watch there. So this is the exact same merge procedure we use to merge these two arrays, to merge this and this array. Okay, because we know the numbers in both the arrays are in their sorted order. So if that is the case, I will compare elements in both the arrays and I will take a new array, and I will, whichever the value is lesser, I will keep on copying that to the new array, Okay, so let us do that. So I will take another array of size m plus n. So which is basically here m equal to 3, n equal to 3. So m plus n equal to 6. So basically 6 size. Then I will put a pointer here, and then here I will compare 1 and 2. Which is smaller? 1 is smaller. So I will take 1. Then I'll move this pointer to the right. Next, out of 2 and 2, which is smaller? Both are same, so I can take any number. So I will take 2 and I'll move further. Now out of these two, which is smaller? 2 is smaller. So I will take 2 and I'll move this pointer to the next number. Okay. Next, out of 3 and 5, which is smaller? 3 is smaller. So I'll take 3 and I am done. I am done because there are only m elements in the first array. So once I move out of this value m, then what I will do, I will simply copy paste the remaining numbers to this particular array, which is 5 and 6. Sometimes the elements in this particular array may exhaust, and we will have to copy the remaining elements from the nums1 array, or in this case it is from nums2 array. So we have a technique to make sure if at all any elements are remaining either from nums1 array or nums2 array, we will copy them to this particular result array. Okay, hope this is clear. With that, we will move to the pseudocode. So now what I will do, so what I need this pointer, I need one pointer here, one pointer here, I need another pointer here, and I need this particular result array. So what I will say, I will take a left pointer pointing to 0, then I will take a right pointer pointing to 0, then I will take my result array of length m plus n of length m plus n, because our merged array will contain m plus n elements. Okay, with this what I did, I iterated, I checked both this array as well as this array until unless any one array gets exhausted, and I kept on comparing the elements and I kept on copying the elements to the result array. So I will do that. So if I want to copy to results array, I need one more pointer, right? So what I will do, I will say I will take an index which is 0. Okay, with that what I will do, I will use a while loop. While left is less than m and my right is less than n. So what I will do, I will compare if nums1 of left, if it is less than nums2 of right, then for sure this number will be smaller. So what I will do, I will say result of index equal to nums1 of left. So after copying what I did, I moved this left pointer towards right and also the index of the result array to the next index. Okay, so I will do that. So index plus plus, then left plus plus. Okay. If that is not the case, then in the else part, so I will use equal to, so less than or equal to nums1 left is less than or equal to nums2 of right, that time I will do this. If that is not the case, if nums1 of left is greater than nums2 of right, then what I will do, I will say my result of index equal to nums2 of right. Okay, then here also I need to increment my index and also increment my right pointer. Okay, so now at the end of this particular while loop, what it does, it copies element from both nums1 and nums2 to the result array. But after this, there is a chance that any one element will be completely copied, but the remaining elements from any one array will still be there. So that is because we check this condition, right? So any one, if it goes false, that time it will stop. So what we need to do, we need to use other while loop. You can also use for loop. So how to use for loop, maybe you can refer the other video what I was talking about, the merge procedure video. So while I is less than m, then what I will do, result of index. So here only I will do plus plus. That way after copying it will increment index equal to nums1 of left. Then this one also I will increment. This will make sure if at all any numbers are remaining in nums1 array, it will copy it to the result array. Then I will use another while statement. This is not I, it should be left less than m. Then if at all any elements are remaining in the nums2 array, then I will check if right is less than n. Then I will use result of index plus plus equal to nums2 of right and increment right after that. Okay, this will copy all the elements from both the arrays to the result array. Now once after this, what I need to do, I need to copy the elements back to nums1 array, because this method, if you have seen the statement, it won't ask you to return the result array. It will check the nums1 array itself so that the numbers are merged and copied into that nums1 array. So what I will do, I will use a for loop for I equal to 0, I less than m plus n, I plus plus. What I will do, nums1 of I equal to result of I. This way we will copy all the elements back to nums1 array. So now if you see the time complexity, so what we are doing, if you see here to the max, we will compare these values, so m plus n values, then we copy them to the result array. So it means this gets executed in order of m plus n time complexity, but here we are also repeating the copy process from the result array to the nums1 array. So basically it is of order 2 into m plus n. This is the time complexity required in this solution. Okay, with that, let us also try to compute the space complexity. We are using the extra space here, right? Because we are using the result array. We are using this particular result array, which is of size m plus n. So that's why it takes of order m plus n space complexity. Okay, so with that, let us try to execute this and see. I will switch. Now what we will do, left equal to 0, okay, and right pointer will also be pointing to 0. Let's take this index which will point to 0. Then let us take a constant array result. Let this be an empty array. Now this will be of size m plus n. With that, let us use a while loop. While left is less than m and right is less than n. What we will do, we will check if nums1 of left, if it is less than nums2 of right, then nums1 is smaller. So I will push result of index equal to nums1 of left. Okay, after this I need to increment my index, then also my left pointer. So instead of doing them separately, what we will do for better readability, we will do that here. Okay, so this will make sure after copying it increments the index and also the left pointer. If that is not the case, then our result of index plus plus will be nums2 of right plus plus. Okay, this will make sure if the number is smaller in nums2 array, it will copy that to the results array. After this, now we will make sure to copy remaining elements. So I will use while loop. You can also use for loop here. While left is less than m, nums1 of it should be result index plus plus equal to nums1 of left. Okay, I will copy the same line. I will use this right, while right is less than n, then it will be nums2 of right. Okay, once this is run, I will copy back elements from result array to nums1 array. So for let I equal to 0, I less than m plus n, I plus plus. So nums1 of I equal to result of I. So this will make sure to copy numbers from result array back to nums1 array. Now I will run this. There is some issue, so we forgot to increment left and right pointer here. We should not do that, otherwise it will go to the infinite loop. So it got accepted now, and let us submit. Okay, our solution got accepted successfully. Now let's switch to editor. So this is our better solution. If you see the time complexity, it is close to order m plus n, but the previous one was m plus n into log of m plus n, which was costly compared to this solution. But if you see, it is taking extra space. So as I mentioned earlier, interviewer will not be happy by seeing this extra space, so we will have to somehow optimize this as well. So how to boil down this space complexity from order of m plus n to order of 1? Let us see that. Now what I will do, I will take the arrays again. Okay, this is nums1 and this is nums2, and I will write the indexes 0, 1, 2. Okay, now what I will do, now somehow I need to merge the elements in place, right? So I will start from the largest number. So now what I will do, I will check which is largest out of these two, 6. So I'll move 6 here. Then again I will check for the next largest. So 5 I'll move here. I will check for the next largest, 3. I'll move 3 here. Next I will check for the next largest, 2. So I will move 2 here. And the remaining elements will be in their place after that. So how to do that? So why only from the largest number? If you try to move by comparing the smallest number, that is from the left, then maybe eventually when you try to modify, that time what you will get, I mean, you might miss some numbers because it gets overridden by some other number. Okay, that's why it is a good idea to start from the largest number, and you need to find its correct position and you need to place it here. Anyhow, our first nums1 array is given with the length of merged array itself, right? So we will use that, and wherever zeros are there, we will keep on replacing them. Okay, now what I will do, I will take 3 pointers this time, one pointing at m-1th index and another pointing at n-1 index. Okay, there is one more pointer we need which points at this particular index, which is the last index of nums1 array. Now what I will do, I will check these two, which one is greater? 6 is greater, correct, right? Now what I will do, I will remove this, I will add 6 here. So since I have already utilized this 6, I will have to move this pointer. So what I will do, I'll move this pointer here. Then I have also used this pointer because this place index, that's why I need to move this pointer towards left. Okay, now next what I will do, I will compare 5 and 3. Which one is larger? 5 is larger, so I will have to move 5. So I'll move 5 here. Okay, and I will move this pointer towards left, and also I need to move this pointer towards left. Okay, next one we will see 2 and 3, which is greater. 3 is greater, correct, right? Then what I will do, now I will replace this with 3, and now I will have to move this pointer towards left, and also this pointer also we need to move to the left. Okay, so then only it will be at its correct position. So this will always try to find the correct position of the number. Okay, so now I have this 2 and this 2, correct, right? So I will simply take this 2 and I will place it here. I will place it here. So this got exhausted. So if any one array got exhausted, then you will have to stop there. But if you see, if right array got exhausted first, then the left array, it will be in its correct position only. Assume we have something like this, maybe 3, 4, 5, 0, 0, 0, then 1, 2, and 3. So I'll do it a little bit fast this time. So I'll put a pointer here, or this is not really required, just I'll put a pointer here and here. So out of these two, which one is larger? 5 is larger. So I will add 5 here. So I'll remove this and this moves here. Now out of 4 and 3, which is larger? 4 is larger. So I'll put 4 here and I'll move here. Out of these two, which one is larger? Both are equal. So I'll simply take this one and I will put it here. Now if you see, this array got exhausted. Now what I need to do, I need to move the elements, remaining elements from nums2 array back to this particular array, correct, right? So now where is this copying pointer? It is somewhere here. Then I will have to take this 3 and I will have to put it here. Then I will have to move. I will have to take, I will have to put it here. Then I will have to move. Then I will have to put it here. So what I'm trying to say, there is chance that we might get some elements remaining still from nums2 array. So that time what we need to do, we need to copy them back to nums1 array. So let us look into the pseudocode for this one. So here what we need again I, okay. So or I will say that is a left pointer and that is pointing to m-1 index, and right pointer will be pointing to n-1, correct, right? And there is one more pointer which is a pointer where we place the number, so that will be m plus n-1. Okay, now what we need to do, we need to iterate until until left is greater than or equal to 0 and right is greater than or equal to 0. If any one array gets exhausted, that is nothing but it becomes 0, this loop will stop. Then what I will do, I will say if nums1 of left, if it is greater than or equal to nums2 of right, then our nums1 of left is a larger number. So what I will do, I will say nums1 of index equal to nums1 of left, correct, right? If that is not the case, but before that we have to decrease this and this pointer. So I will say index minus minus and then left minus minus, correct, right? Now if that is not the case, nums2 of right will be the largest number. So what I will do, in the else part, I will say nums1 of index will be nums2 of right, correct, right? After this I will have to do index minus minus and also right minus minus. Okay, so this will copy all the elements to nums1 array. But we also saw, right, there must be some elements which might be still remaining in nums2 array. So we will have to try and copy them back to nums1 array. If at all they are there, then what I will do, I will use a while loop while right is greater than or equal to 0 until unless nums2 array gets exhausted. What we need to do, nums1 of index, I will use minus minus here only because we will have to decrement that index, equal to nums2 of right, then I will have to decrement that. So this way all the elements get merged and placed in nums1 array. So now if you see, we did single iteration from both the arrays, and with the time complexity order of m plus n, we copied all the numbers into their right position. And important thing is our space complexity is order 1 because we are not doing taking any extra space. Instead we are doing it in place. Okay, so this is the most optimal solution. Let us switch and let us try to execute this. Okay, so I will remove this code. My left will be m minus 1, my right will be n minus 1, and my index will be m plus n minus 1. Okay, now what I will do, I will use a while loop while left is greater than or equal to 0 and right is greater than or equal to 0. What I will do, I will check if nums1 of left, if it is greater than nums2 of right, then we know nums1 we need to copy it to nums1 of left to nums1 of index equal to nums1 of left. After that I need to decrement my index and also my left pointer. So instead what I will do, for better readability, I'll comment these two. I will do it here, minus 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 minus. Okay, if this is not the case, then my nums1 of index minus minus equal to nums2 of right minus minus. Okay, now after this particular while loop, we need to use another while loop and try to copy, if at all, any remaining elements from nums2 array. So greater than or equal to 0, we will say nums1 of index, we will decrement index after the operation, then I will say nums2 of right, then we will have to decrement the right pointer as well. So this is it. Let us try to run and see. This got accepted. Let's submit and see. So our solution got submitted successfully. So if you see, this is the most optimal way of solving this particular problem. Hope you liked the explanation. If that is the case, please consider subscribing to my channel and also like the video, share it with your friends. And also if you have any feedback or any comments, you can add that as a comment, or if you have understood it well, then you can add that as well. Thanks for watching the video.